also this side now parallel with the both the plane. It is parallel with horizontal plane also, and it is parallel with vertical plane also. And you can tell also this side also parallel with horizontal plane, but this side is not parallel with vertical plane. It is now perpendicular with the vertical plane. So we considering this one. This is initially the initial condition has been satisfied, and we can get the plan. This is the plan. Now, can you tell me how many points are there? We considering on the bottom side A, B, C, D, 4 points, and now on the top side we considering 1, 2, 3, 4. Now, can you tell me how many points are there on every corner?
2.
2. So now if we just start from here 1, this is 1, 2, 3, 4. I am telling on the bottom side it is A and alphabetic name, and on the top side numeric value. Now, so in that case, you will put here B, C, D, and A. So in that case, 1 is on the top, so we write here 1 by A and bottom A. Then 2 is on the top, so we write here 2 by B, and then 3 by C, and then 4 by B. Any doubt up to this? Tell, any doubt?
Sir, can you repeat, sir, the question, please?
Question. So draw the projection of a square prism having base side 25 millimeter and height 70 millimeter, resting with its square base in such a way that two base sides or two top sides are parallel with both the frame.
Okay, sir.
Now, any doubt up to this? This is the plan.
No, sir, understood.
Yes?
Understood, sir.
So this is the complete plan. Now you have to draw the elevation with the help of this plan. So we know, and you can draw the projection from this point. You also draw the projection from this point. And though we have a height given, so you can measure from this. Though it is resting with its horizontal plane, so baseline will be touching on the ground line. Okay, and here 2 points are there. Here also 2 points. Now, can you tell me what is the name of these 2 points here? Tell.
B and A.
1 dash, comma 2 dash.
B and C.
This is B and A because B alphabetical name is on the bottom side. So this is you first, while you are looking from this direction, you first see B, C, first see B, then A. So you can write B dash by A dash because it is elevator. Similarly, tell what is the name this one?
C dash by D dash.
D dash by D dash. Okay. Now from here, measure 70 millimeters because it is a height of 70 given, and start this point. Can you tell me what is the name of this point? Tell.
2 by 1.
2 by 1 dash. Okay. Similarly, plot here another 71. You draw the parallel line with this one. It is meeting here, and this will be C dash by 4 dash. Okay. So this is your complete elimination. Now, any doubt? Okay, any doubt? Now we just want to add. Now in this condition, uh, in this condition, we just add some additional condition. Here, right now, can you tell me rectangular surface that is, if we consider 1, 2, A, B is also a rectangular surface, and also right hand side, if we consider CD and 4, 3 also another rectangular surface. Now, can you tell me the rectangular surface that is right now what angle making with horizontal plane?
Perpendicular.
0 degree.
Perpendicular, yes, 90-degree angle. Right now, two left hand side and right hand side rectangular surface, and both top and bottom also rectangular surface making 90-degree with horizontal surface. But we just want to add some other condition, that is rectangular surface making some angle with horizontal plane. Then can you tell me, if it is rectangular surface making some angle with horizontal plane, then is it possible the base surface is wholly resting on the horizontal plane?
No, sir.
No,
Suppose
sir.
this is your, it is right now in this condition it is resting, and we get the elevation on the blackboard and plan also. Now, if it is, this surface is now perpendicular with HP. Now I want to make this surface like this, some angle with the horizontal plane. Then is it possible? Total square surface is resting on the horizontal plane? Not.
No, sir.
No, no, sir.
Now it is resting on the one edge, like this, one edge, and this edge. Okay. So now I am considering this rectangular surface making some angle with the horizontal plane. Maybe other side also. If it is this one, then you can rotate like this. It is making some angle with the horizontal plane. Then how the change, elevation and plane will be changed? Can you tell?
Sir, from B dash to A dash we draw a straight line, and by using compass we draw the curve, and by using the angle.
Angle. We just now our question is, which edge we consider which will be resting on the horizontal plane? It may be C dash D dash or maybe B dash B dash. If we consider B dash B dash, then you can easily make a angle, specific angle, okay, and then copy this rectangular surface in such a way that it is inclined with this line. Okay. So now, though it is overlapping, if you are making this one here, this rectangular surface here, then if you draw the projection, then overlap plane is coming on the previous figure. So in that case, we just shifted this point. In that case, we shifted D dash here. We start here so that we can isolate the plane elevation. Okay. So now we just shifted. This is a rectangular. So now, suppose we are making this one in this way. So now, can you tell me why you are just rotating this one and making this rectangular right hand side rectangular surface making horizontal plane 60-degree? Then can you tell me any change shape of elevation or plane? Please respond. It is in this condition, then just rotate like this. So now can you tell me if there any change on elevation, shape of change, shape, not orientation.
Parallelogram.
No, sir. No
Rectangle.
change.
No, we are
No
not.
change.
This is the initial elevation. So while we rotating in this condition, now can you tell me any change of shape of elevation, not in orientation, in elevation or plan? It is like that.
Yes, sir.
Yes, what? Any
It will
change?
change, sir. Yes, sir.
Change.
So safe will
Yes,
not
sir.
change.
Shape is no change. You just rotating like this. You are looking from this direction, you see a rectangular surface perpendicular to horizontal plane. Now we are rotating like this. Then any change on rectangular shape?
No, sir. There's no
Shape will
change.
not change, sir, but
No, sir.
it,
Orientation will be changed. Okay. But now can you tell me any change on plane?
Yes,
Why?
sir.
Yes,
Yes.
length will
Yes.
change, sir.
plane will be changed. So I
Yes,
have
sir.
now you just shifted this leaders here, and then I have just add the second condition. Rectangular surface, one rectangular surface making 60-degree angle with horizontal plane. Rectangular surface making 60-degree angle. So you just make 60-degree angle this side, right hand side 60-degree angle like this. Draw this one and then measure from this 70 millimeter, and this is not here, and this is also 3 dash by 4 dash. Okay, and then after taking this one, you just copy this rectangular, both rectangle here. Just making perpendicular line. Here also perpendicular line. Okay, and then cut the side and then join it. And you put the name here. This is B dash, A dash, and this is your 2 dash, 1 dash. Okay. So you get the rectangular, you get elevation. It is completely same as previous elevation, but orientation will be changed. Only 60-degree making angle. This is 60 degree. Okay. Now, how to get the final plan? You know already in case of projection of lamina, you get other views with the help of projection from. If you want to draw the plane, so you have to draw the projection from this point and then corresponding point on the previous plane, which intersect, and we get the final plane point. So I am coming, start from this point. Now, before that, we discussing there are so many edges we cannot see while we are looking from the top. Suppose it is resting in this way. So can you tell me while you are looking from top, can you see all the edges?
No,
No.
sir.
No,
Which edge you cannot see?
Bottom. Sir, the lateral edges.
Lateral edges.
C3, CD43.
Only one edge you cannot see, which is resting on the ground line. That is C dash D dash. Do you understand?
Yes,
Yes,
sir.
sir.
You can see all the edges. These edges you overlapping while you see this one and this one is the same line. But you completely cannot see the resting edge. Okay. So which edge you cannot see while taking some views? That edge should be dash line or dotted line. Okay. Now, so I am starting from B dash A dash. Draw the projection line, thin line, you know, and B here. Draw it. You find a point. This is B. And A here. This is A. Then from this line, draw projection and Here it is coming a point. What point is this one? Is
D.
D. What is this? C. Okay. Now draw a projection line from here. Tell what point is one?
1.
1. What is this? 2. Then draw the projection and tell what is the point?
4.
4. This one C. Okay. Now after getting this one, you can easily dot the boundary line. All the edges. Okay. Now one line on the middle, and here also a line because this is the top line. One dash to dash you can see why you are looking from top from direction. This arrow means you are looking from top, and this one dash to dash you can see and it is visible so it does line. But only one line C dash D dash C D you cannot see. Then you put the dotted line. Okay, so this is your complete plan. While this rectangular square prism making 60-degree angle with a rectangular surface. This is your final elevation. This is your plan. Any doubt up to this?
No, sir.
Now I add some other condition in this problem. How? You know, this is C dash D dash resting on the horizontal plane. Now, in what condition is related with the vertical plane? Can you tell me?
30 degrees.
Now, in this condition, it is in what condition? The vertical plane.
90 degree.
It is perpendicular to vertical plane, making 90 degrees. So now I add, it is not perpendicular. I add this resting edge is making 45 degree with vertical plane. You add, everybody add this condition. This resting edge is 45 degree with the vertical plane. Okay. So now, how to start for adding this condition? Can you tell me please?
Sir, making 45 degree line.
In this condition, suppose it is up to this it is lying in this condition. So in that case, though it is this is a resting edge, okay. This is a resting edge. This one a resting edge. Now, if we and this edge is making 90 degree with the vertical plane, we want to make this line 45 degree with the vertical plane. Then you just rotate like this, okay. So now it is in this condition, you rotate like this. Now can you tell me which views, elevation or plan, shape will be same but orientation different? It is rotated like this. Shape will be same.
Plan.
Plan, yes. Plan, shape of plan will be same, but orientation will be different because it is making 45 degree. But shape will be same, only plan, elevation shape will be changed. Okay. So now you can rotate the plan in clockwise direction or anti-clockwise direction. You may rotate like this or like that. So now can you tell me, when we rotate like this, what surface, bottom or top, you can see completely?
Sir, bottom surface.
Bottom surface, you can see the bottom square edges and the surface completely, but you cannot see the top surface completely.
Yes, sir.
Okay, now if we rotate like this, Then what happened?
Sir, we can see now only the top surface.
Top surface, but bottom surface we cannot see. Here,
Yes, sir.
an important point. While you are rotating in this condition, say you are rotating like this. So here there should be a dotted line on elevation which you cannot see. So you are confusing which line is dotted and which line is continuous. So there is a policy that there is a method to find the which line is dotted and which line will be not dotted. So here, if we just rotate like this, now can you tell me on the top side you cannot see a corner point. Out of 4 corner points, you cannot see 1 corner point. Am I
Yes,
correct?
sir.
Am I correct?
Yes,
Yes.
sir.
Yes. So you have to find out the line which is connecting to that corner point. All line will be dotted line.
Sir, the back line and the upper 2 lines.
Yes. You just find out first which corner point you cannot see. And connecting all the line to that corner point will be dotted line. Okay. So one
Was
rectangular
it point
surface
4
edge.
dash?
Yes, one you cannot see one rectangular surface edge and 2 square surface
Square
edge.
surface.
Okay.
Yes, sir.
Now, if you rotate like this, here different, you can see 4 lines on the top, but you cannot see one corner point on the bottom side. Okay. And all line connecting to that point you cannot see. That will be a dotted line. So this is the method for finding out the dotted line. Okay. Now here, so in the third condition, plane shape will not be changed. Only you just rotate this plane clockwise in such a way that this dotted line making angle 45 degrees with the horizontal. Okay. Or you may rotate anti-clockwise such that this dotted line making 45 degrees with the horizontal. And one important another point, I am making this problem with the northern scale with 3 hands. So this dotted line may become this right hand side, left hand side of this line, or maybe right hand side of this line. Okay, when you make that is not no confusion, you can take. I think it is coming in this side also, maybe here. That depends on the height of the cylinder. Okay. So now, if you rotate this one clockwise, see this one clockwise, then while you are facing here, then a point may be just beyond the XY line. So in that case, you consider the whole figure rotating anti-clockwise like this. Then your 45 angle will be like this. And if you rotate clockwise, then 45 angle will be this one. And dotted line is coming here and your figure is coming like this. Okay. Now I am rotating this figure you can rotate clockwise because this chain is smaller than that one. Okay, this chain is smaller than that one. So you can rotate clockwise like this and make a 45 degree here. Okay, and this is the 45 degree line. This is your 45 degree, and you can place.
Sir, this is anti-clockwise, right?
Okay. Sorry. This is, I am just rotating clockwise like this. That means you have to draw 45 degree like this. Okay, this is 45 degree. Now you just put this is B and C on that line. So now can you tell me B is on the top side or near to XY line or C is near to XY line in that case?
So D will be on the top.
Yes, D will be on the near to XY line. So if you just put here B and then measure this length and this is your C and we put this and then the dotted line. Okay, now you can easily copy this figure, copy this whole figure. I am just putting here, just hit this one because here space is not there. This is your D, and you put D in such a way that this A is not beyond the XY line. D and this is your C, and you just put the dotted line in this one, and then copy this figure. Dear student, are you doing in your exercise book?
Yes, sir.
Yes,
Just
sir.
copy this figure, and this is C, and I think it is A, and this is your B, and this is your 1, this is your 2, and this is your 4, and this is your T. T. T, am I correct? See, now you have to draw the projection from plan point and also draw the projection from the elevation side and you find the intersecting point and then you find the complete elevation. Now can you tell me why is just rotating clockwise direction? Can you tell me which corner point we cannot see?
D.
Hmm? Understand again. While rotating clockwise direction, which corner point you cannot see?
C, sir.
Yes?
C. Sir, I think
C
it's
and
two.
D, C and D is resting on the ground line. I think you see C,
Sir, I
D
can see
both
two.
points.
The B.
So you can see the 2 point, no, sir.
A.
Yes. You cannot see a point. Why? Because simple, very simple. You see here. You are looking from that direction. Okay. So can you see this point? A point?
No, sir, you can't.
And C and D is on the ground line, so you can see that one
Yes,
in
sir.
this area. It is like this and it is rotating like this. So C is D on the ground line. You can see from your side. But you cannot see this point. That is which one? A.
Yes, sir, A point.
So you
Yes,
cannot
sir.
see A. So now can you tell me which line you cannot see?
AB and AD.
D.
AB and AD
A.
and also another line.
Sir, AB.
AB and AD.
A1.
A1, yes, that is rectangular surface A. A1 you cannot see. Okay. Now, anybody can show how it is coming on the elevation. Draw and show me. Have done anybody? In this class, attendance is very important. Those who are not attending the class, I think they will not, their score will not better. So everybody should attend. And at the time of Viva, we just take your class notebook. No, can anybody done? Have you done, anybody? Yes. I think nobody has done. Am I right or discuss?
Sir, we are doing.
So, after finish, show me. Have done.
Yes, sir.
So, put on your camera and show it. Show. Sharat.
Yes, sir.
Close to camera. Yes, very good. But some problem is there on the top surface. You don't show the square face. That's okay, but okay, you are trying. Okay. So now I am coming. How to get all the points by projecting this all points from the plane. Now I am considering A, B, C, D. A, B, C, D. Considering the bottom surface of the square thing. First we consider A. This one A, draw the projection line, and A is here, A, B colon here. So this is your A and B is here, this is your B dash, okay. And now I am coming C. C is on the ground line, okay, C is on the ground line, C dash, and this is D, D also on the ground line, this is D, D dash, okay. Now I am just, so always you just remember for projecting some object always boundary, all the boundary lines should be dark line. There is no dotted line. Okay. So you can connect these one. This is the boundary line and baseline you want to see. Okay. Now we just put it is sitting here. And now I am coming 1, 2, 3, 4. So first you draw the projection from one point, and it is coming from this side, this point, this is one there. And then from 2 is on the same line, this is 2 there, okay. And then from 3, it is coming from this point, 3 there. And then it is from 4. 4 is on the same line of the 4 there. Now, while you are rotating on that side, you see on the top surface completely. So you can draw the form line completely 1 to 3, 4, 1 to 2, 2 to 3, 3 to 4, and then 4 to 1. Okay. Now I am saying that you can see always boundary of the line as a dark line. So boundary means B2, 2, similarly go to B, and similarly this is B2 C dash, which is in front of you. You can connect this line. Okay, and now though you cannot see a point, A dash you cannot see, so connecting all the points with A dash will be dotted. What will be that one? Obviously, A to 1 will be dotted, and A to B, this one B, A to B will be a dotted, and A to B will be a dotted. Now, can you visualize the complete elevation?
Yes, sir.
So now, if rotation is not clockwise, anti-clockwise, then different figure will become. That is no matter. You can rotate on that direction also. So this is the complete elevation. So now can you tell anybody the complete problem? What is the complete problem? Tell anybody. Hello, tell.
Draw the projection of a solid rectangular block.
Solid, not solid. The square
Rectangular
prism.
block.
Square prism.
Prism.
Square prism.
So this is a block, no? It's not a prism.
Yes, it is a prism. It is a square prism having height, some
Oh yes.
length and height.
Yes, sir. I thought of triangular prism in physics and all of this. So project a square prism. One.
Having one side dimension is given, height is given,
Okay.
and
Resting on the horizontal plane
with its
with one of its side
one of edge or side.
One of its edge or sides perpendicular to the horizontal
No,
plane.
not perpendicular. It is just finally problem. Edges in such a way that dash edges is making 45 degree with vertical plane.
Okay.
Okay.
And one of its edges also inclined at a certain angle to the.
A rectangular face containing that edge, which is resting. A rectangular face containing that edge, making 60 degree with the horizontal.
Understood, sir.
Okay. So now If another condition is there, suppose this CD is resting A and this B point is near to XY line, near to vertical plane. Okay. If it is specified, some length is given. Suppose this is given X millimeter distance from the vertical or XY plane. Then what you have to do? You just make a 45-degree line. Then maintain this distance, draw a parallel to XY and find the intersecting point. And this point should be G. Okay. Now everybody go through your problem sheet. Everybody go through your problem sheet. Projection of solid. You just match the problem 1. I think 1 is the same which I discussed here. Okay. Now, anybody can read the problem 2.
So draw a plan and elevation of a right hexagonal prism, base edge 20 millimeter and height 50 millimeter, having one of its base edges on horizontal plane and inclined at 45 degree to XY.
Yes.
Rectangular face containing the edge being inclined at 30 degree to horizontal plane.
Now, can you the same problem with the problem 1? It is same. Maybe shape is different, but is it same? Hello? Tell anybody.
Problem.
It is
Yes,
same.
sir, same.
Space
Same,
is
same.
where it is I think
Hexagonal prism.
hexagonal base. Okay. Otherwise same. So you should initially place in such a way that two edges, hexagonal two parallel edges is perpendicular to vertical plane. Okay. In that condition, you got the two rectangular surface which is perpendicular to HP. Then you can rotate. Okay. Now, anybody can tell the problem 3?
Set a tetrahedron, length of edges 50 millimeter, rest on horizontal plane, one of its edges with one of its face, making an angle 30 degree with the vertical plane.
Yes.
Draw plan and elevation of the solid when the nearest point is 10 millimeter in front of vertical plane.
Yes. So now I am coming. Can I erase on the blackboard?
Yes,
Yes,
sir.
sir.
So now I am coming how to solve the problem 3. This is a tetrahedron. In the same problem, you have the problem 3, the same problem. Okay. Now, you can rest this tetrahedron in such a way that, initially, in such a way that one side will be perpendicular to vertical plane. One side is perpendicular to vertical plane. Okay. So, in that case, can you tell what it is on the plane? You should start from the plane. What will be the plane? One side is perpendicular to vertical plane. You just start the length of side 50 millimeter, and then it is a regular tetrahedron. So plane will be what? Which type of triangle? Tell.
Equilateral.
Equilateral.
Equilateral triangle having 50 millimeter side. So this is 50 and cut center here, and by taking a 50 millimeter with your compass and cut a arc here and that side here. Then you connect. And this is a equilateral triangle. Now just I am putting the name. Tetrahedron name, all four corners will be 1, 2, 3, 4. Okay, so here 1, 2, 3. Now can you tell me where the fourth? Where the location of the fourth?
Sir, it's on back side. We can't see.
You don't?
Back side, sir. We can't see it.
But no, if it is resting in this like this, suppose it is resting on the base 1, 2, 3, 4, then 4 will be here.
At the centroid, sir.
Yes?
At the centroid.
Yes, yes, it is a center. 4 will be center on the center of this equilateral triangle. 4 will be here. So how to find the center point of this one? This triangle? You can draw the perpendicular bisector of two sides. Okay, and you find intersecting point. This will be 4 points. Okay, this will be 4. Now is it complete plane? Tell.
So we have to join 4.
Yes, 4 to 1. There is 8. Slant edge. This is slant edge. 4 to 1. 4 to 2. 4 to 3. So this one, and this one. You consider this is a equilateral pyramid, and 4 is a vertex. Okay. So this is your complete plane. Now can you find the elevation with the help of this figure? Very easy.
Yes, sir.
You draw the
Yes, sir.
1 to 2. 1 to 2 will be on the ground or just on the air?
Yes, sir.
It's
Ground.
ground or air?
Ground, sir.
Ground. This is 2 dash and 1 dash. And from 3, it is ground or air?
Ground.
3 dash. And this is 4. It is ground or air?
Air.
Yeah. Then how the locate position of 4 here on that line? Tell. Only given data is a tetrahedron having 50 millimeter sides. Tell how to locate that point on the air. When you find the true length of a edge, while you are projecting on elevation or plane side, when you get the true length of edge,
When it is parallel to the plane.
yes, when it is parallel to any plane. Suppose if you are just want to see the true length on elevation, then that side will be parallel with ground line or with vertical plane. So which line is parallel with ground line or vertical plane? Tell. Which edge? 1 to 2 or 2 to 3 or 3 to 1 or 3 to 4. Which edge is parallel with vertical plane?
Sir, the central line.
What central line also parallel? That's vertical. But which edges other than central line? Which edges will be parallel with vertical plane? 1, 2, 2, 1, 2, 2, 3, 3, 1, 3, 4.
Sir, 1, 2.
1, 2 is perpendicular with the vertical plane.
Sir,
3,
3,
Sir,
4.
no line.
Yes, yes,
Everything is
yes,
a
yes.
angle.
Yes?
No line. Every line is in angle.
Why 3, 4 is parallel?
Yes, sir.
Yes, sir.
This one, 3, 4 is parallel.
Yes, sir. 3, 4
Okay.
parallel.
So you can see 3, 4 line on elevation side as a true lane, which is given 50 millimeter. So already location of P is given, already you get. Then how to find the 4 line?
cut an arc.
Yes, by taking your with your compass 50 millimeter centering here, start on the central line. This is your port there, and then connect. Okay. So this is your complete elevation. This is the central line. You can draw as a central line like this. Okay. This is your elevation and plan. So what is the problem? How you define related with this elevation and plan the problem? Problem is a tetrahedron having side 50 millimeter resting with its one triangular surface in horizontal plane in such a way that one side is perpendicular to vertical plane. Or you may tell one side is parallel with vertical plane. Am I correct? Okay. But in your problem, another additional condition is there. It is not resting with its triangular surface. It is resting with its one uh, edges. Edges. Okay. So now, if we consider that edge is 1, 2, then how you start from the elevation side for getting the plan and elevation? It is the same. Okay. So though it is resting with its one not surface, one edges, so you can rotate like this. Okay. You can rotate like this.
Yes,
That
sir.
means is the elevation shape will be changed or not while you are rotating?
No,
By
sir.
keeping the resting edge perpendicular to vertical plane, you are rotating like this. Is elevation shape change or not?
No, sir.
Shape will be not change, only orientation change. But you have also another condition. We are just combining two conditions and make it position. And it is telling in your problem that the resting edge, the triangular surface related with the resting edge. So if we consider this is the resting edge, so triangular surface is that one. Okay. So that triangular surface making some angle with the vertical plane. So now in this condition, triangular surface is making uh, uh, perpendicular to vertical plane but making horizontal plane some angle. So while you are giving some angle with vertical plane, that surface, triangular surface, you should
Yes, sir. 30 degree.
you
30
should
degree.
you should make that surface initially perpendicular to vertical plane, both the plane. Then you make rotation. While it is asking surface is making some angle with the vertical plane, so initially you should make that triangular surface or that other rectangular surface initially make perpendicular with the both the plane. Then give the rotation. Okay. So now if we consider 1 to 4 triangular face. Now it is condition. What in condition? This surface is
30 degrees.
No, not this surface is perpendicular to vertical plane, but making some angle with the horizontal plane. We do not know what is the angle. So this angle measure, if you measure this one, this angle will be the angle horizontal plane. So now I want to make that 1 to 4 surface perpendicular to both the planes. Then I think if it is coming like this, that 4 just one line is coming in this way, then it is this is having this is 4 and this is 2 dash and 1 dash. So it is what? It is a triangular surface, and so it is perpendicular to both the plane, and you can see a straight line. So it is this surface is perpendicular to both the plane. Tell. It is in this way.
Yes, sir.
Now we are rotating like this. So this surface is perpendicular to vertical plane also and also horizontal plane. Okay. So you have to copy this figure. Copy this figure in such a way that four dash and two dash one dash coming perpendicular with the x-y. Okay. Then just copy this corner by taking centering here, taking radius and draw from here measurement and draw. Then connect this and you find this is your see there. So this is your elevation. In what condition? It is in condition that resting edge triangular surface is now perpendicular with the both of them. Okay. Now very easy. How to find the plane of the object on that line? How many points are there? Four points are there. So the projection line and one. This is one there. One. Sorry. And this is two. Two. And this is four. So 1 to 4 is also one plane which is coming in the one line. That means surface is making perpendicular. Okay. And you connect this one. And then from 3 draw the projection line. And 3 on the same. This is 3. So now you connect all that point and also for 3 you can see. While you are looking from this direction, you can see for 3 and all other points. Okay. So 4 is coming here on the middle of this line. Any doubt after this? Now it is telling, now this resting edge triangular face is perpendicular with both the planes. But it is telling that triangular face making some angle with the vertical plane. Then which one will be rotated, plane or elevation on the 30 degree?
Plan.
Plane. Okay. You just make the rotation, that is clockwise direction. First you draw a 30-degree line. Okay. Then copy this figure in such a way that 1, 4, 2 is coming on that line. And I think some other condition is there. While you are rotating in this way, can you tell me out of two resting corner, which corner is near to equal line?
1.
1. So I think some distance maintaining in your problem. So
10 millimeter.
10 millimeter, sir.
10 millimeter, measure a 10 millimeter power line this point and locate this point as 1. This is 1, that's 1. Then measure 1 to 2 and 1 to 4. This is your 4. And this is your, suppose this is 4 and this is your 2. And then cut it. Draw the perpendicular line and cut this length. Yeah. Just copy. Okay. And this is your P. Now, this triangular plate making vertical 36 is vertical plane and perpendicular to horizontal. Now you can easily get the projection and find the. Now, here it is in this way. It is resting like this and rotate like this. Now, can you tell me? You cannot see one edges. Now, draw the projection. One is on the ground line, one dash. Two is also on the ground line, two dash, and four is also on the air. This is four dash, and three here. This is three dash. Now you just connect all boundaries. One to two, two to three, three to one, and on the ground 1 to 2. And one line you cannot see. Can you tell which line they are on? Hello, tell.
Four.
1, 4.
4 1, 4 1,
1 4.
4 4 1. You cannot see this line. 4 and 1. Okay. Sorry. You are rotating in this way.
Sir, 2 dash 3 dash also can't be seen.
2 3 you can see. You just rotating like this. Yes. You can see the triangular face, this face. So
Yes, sir.
you can see this one. Can you visualize this one, this figure? If rotation is anti-clockwise, then this will be changed. Okay. So this is your problem 3. Any doubt? Tell. Now, problem 4 is a cube. It is a problem of cube. You try yourself. And problem 5 is the same as problem 3. Problem 5 is the same as problem step by step. But first you draw the plan and elevation, then make it perpendicular line, then draw the projection and rotation and then problem 3 and 5 are same. Okay. Now, 7 is a cone, projection of cone. So I am just giving the hints how to start other projection of cones and cylinders. Some noise is coming. Mute yourself. So why you are just taking the cone like circular lamina cone initially you are resting on the cone on the horizontal plane. You see the elevation like this and also you see the plane, a circle, and in that case Though there is no edges, in that case, you should divide this circumference into 12 equal parts. Okay, like this. And put the name 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And vertex and O. So automatically it is coming over there, and this will be 1 dash and this will be 7 dash. And on the middle there will be there is 2 lines overlapping. Okay. So how? Get 2 to 12, draw a section line, and this is generating. We consider this is generating line. And 3 to 11, draw the projection, this is a line. And 4 to 10, this is a line. And 5 to 9, draw projection, this is a line. And this is 6 to 8, draw projection, this is a line. So this is your complete elevation and plane of the cone. What is the problem? Problem is that a cone is resting with its circular surface on the horizontal plane. Simple resting with circular surface in horizontal plane. Draw the plane and elevation. Okay. So it is very simple. Now if we add another condition, it is resting with its one point on the circumference of the base and axis making an angle maybe 30 degree, maybe some angle with the horizontal. Then what will be the elevation and plane? Plane. So the axis means here, axis is lying here. Now we consider it is resting with not on the surface, resting on one point on 7 point. Then you just make a axis. This is axis initially, axis making some angle given. Okay, and then now, how to, if we consider 7 is the resting edge, so how to find out this length initially, this length, and from here, how to find out this length? This length means, if it is 7, this length means this one. Okay, so how to, after making axis angle, how to make this one? So it is better, here, you have to find out if axis making an angle 60 degree, then this line is what? This line. Okay. So now, if axis making 60 degrees, what is the base angle with the horizontal?
30 degree.
Yes, 30 degrees. So it is better if you start from the base angle 30 degree. You after just find the base angle. If it is axis making 30 degrees, then base angle will be 60 degrees. So how to start? If you start with base angle, initially you consider 7 is here. 7 is here. Okay. Make 30 degree angle. If it is doing 60 degree with base axis angle, then make 30 degree angle and cut the diameter. This one. 7 1. 7 1 here. 1. Okay. And then middle line as axis line. You just draw a 60 degree axis line. Okay, then cut the vertex order. Then point out all the points here. By measuring from this, all the points, measuring from this, and similarly here, and how many lines are there inside? This is your extreme line, this is your extreme line, and then 1, 2, 3. 1, 2, and this is the middle line. 1 and 2. Okay. So this is the elevation. Now how to get the plane with the help of these two figures? Tell.
So project perpendicular lines and also from the circle project parallel lines.
Yes.
Then we got the
Try to
points
be
and edit.
Put the value here. This is 212, C11, there's all there, 14, 5, 9, 6, 5, 9, 6, 8, and 7. Here also, this is 212, C11, all are there, 14, 5, 9, 8, 6, 8, 8, sorry, 5, 9, 6, 8. Okay. Now, draw from the, immediately draw the vertex. So this is vertex, this is O. Now, can you tell me why this circular surface is inclined in the horizontal plane? While you getting the plane, is it circular or any other shape?
Sir, become ellipse, no, sir.
Yes. Okay. So if you find all the points one by one on the this side, you can if you connect all the points with the base class, you get like this. So first from one. One is here. Then 2 to this is 12. 2 and 8, 12 and 8 is coming on the same line. This is 12 and 2. This is 2 and then 11. This is your 11. 1 point. This is your 3 and 14. And extreme. This is the 10. Extreme point. This is your 4. Extreme point. And 5, 5, 9. That is 5, 9, 11, 9, you extreme and you find this one. And this is 3, 3 I think. 3, 5, extend, you find. And this one, extend this line. Extend this line. And then 7. This one. So you got the clear point. So then, now, this is extreme generator over to there, this one. While see your scale, can make there, initially you just draw this one. And then change. So now one important point, while you are looking from this top, can you see all the edges of elliptical part?
Yes, sir.
No.
No, sir. No, sir.
The bottom point cannot be seen.
Yes, from just tell the specific point from what it is resting like this. This is a cone, okay, it is resting like this. It is resting this 7 point. So while you are looking from top, you can see middle from here to this surface you can see, but from bottom surface you cannot see. So can you tell me specifically which point you can see and which point you cannot see? This is 4. This is 10. And this
Sir,
is 7. Yes?
10 is above, sir.
For to this side you cannot see because it is on the bottom. For to this side you cannot see. For to 10. So it is coming as a dotted line. But you can see this side because it is lying on the top. Am I correct? Now, yes, any question? Now you put your plane on 0 point and put this line with a tangent and connect this one. Similarly this side. Okay. So this is the plane. Now I am coming the problem same to Problem 7. Problem 7 has two parts. Anybody can read the question 7.
So draw the projection of a cone, base 50 millimeter diameter and axis 75 millimeter long.
Yes,
When
see, base diameter is 150, axis means from here to here 70. Then
when it is resting on the horizontal plane on a point of its base circle with
this one, 7. Then
question number A, the axis making an angle 30 degree with the horizontal plane and 45 degree with the vertical plane.
yes. So now axis making 30 degrees telling, but I am just taking 60 degrees say this is 60 degrees. Sorry, 60 degrees. It is already 60 degrees. But telling 45 degree with
Vertical plane.
vertical plane. But now it is 45 degree with vertical plane.
No,
So
sir.
all these horizontal plane we just considering. Vertical
Yes,
plane
sir.
is now this axis is parallel to vertical plane.
Yes, sir.
Okay, if we consider the axis just like a straight line, it is now straight line O dash O by 4 straight line is parallel with vertical plane and inclined with horizontal plane. Now if we consider both angle projection of straight line, then you have to start another problem. Okay, another plan and elevation, final plan and elevation. Okay, now one important point, while it is combined angle, HP and VP, so that angle, HP angle and VP angle should not be greater than 90 degrees. Otherwise, you cannot solve the problem. Okay, so if it is 30 degrees, 60 degrees, then it is 45 degrees, then it is not possible. So you should make it 30 degree and then 45 degree.
Then that means the summation should not be greater than 90 degree.
Yes. Then now part one. What is telling? In part one, it is telling the axis making an angle with HP 45 and B. So if we compare this problem with the straight line, when it is telling that the straight line making an angle 45 degree with vertical plane. And also it is telling that plane of that straight line making an angle 45. Then what is the difference? Suppose we are considering the straight line. Only straight line. Let's a straight line problem. This one A dash, B dash, A, B, and this is the B1 dash and a B1. Okay. So in straight line problem, what we are seeing in straight line problem, this is a straight line making an angle with the vertical plane phi. Okay, but this is angle making an angle beta with vertical plane, and this is what? This is a plane.
Plan.
What
Yes,
is
sir.
the straight line? Okay. So for finding the plane and variable, this is given. In your problem, this is axis making an angle. That means two straight line making an angle. Okay. So why is the axis making an angle? So you got the axis plane, then draw the locus and find out the plane from this figure. Axis plane is this is the original axis and this is the equivalent axis. This is center point. So center here card and draw the location. Then copy this figure. Then you have to solve. How? I am considering part one. This is part one. Okay, and axis making an angle how much? 45 degree. So you first initially draw a 45 degree. You just rotate the clockwise here. 45 degree angle. Okay, then axis making an angle. Then you just locate. This is the O, initially O, and this is length axis means original length O to 4. Major gas this is 4. This is your 4 dash straight gas. Okay, sorry 4 and 10. And this is your row. This is axis means this length 75 millimeter. Okay, now draw the local right straight line. Then take the plan length of this. Axis means this was the plan length. Am I correct? This axis and this is plan length of this one. Then here start a point. Then draw this is the plan of axis. Now
Please repeat, sir, the last part.
so this is the axis.
Yes, sir.
You got axis here, right straight line. Axis
Okay, sir.
is horizontal straight line. Then draw the loca, and this is axis, and as well as this is the plane of axis region.
Yes, sir.
Then centering here, got that plane on that line. You find
Yes,
the point. This is the actual orientation. So, then by putting this O, that 7 here, we should copy this figure. How? In the same point, like here in the there are so many parallel lines. Okay, a line in this line, and you should draw that parallel line like this, perpendicular to that one, and locate 12 point here, and draw this ellipse, and this part is dotted, inner part, and then draw the tangent line. This copying figure is completed. Okay. Parallel line, I think I discussed to you how to copy this one, circular lamina.
Yes, sir. Ellipse.
Yes, sir.
Copy this one, perpendicular line, copy. Then draw the projection, you find this is rotation is forward, so you cannot see the base. This is the resting point, 3 point, 7 point, 7 point is resting point, and you just sorry, it is coming like this, and vertex is coming here, and you cannot see the base, so it is a dotted. It is coming dotted. Okay. Now in part 2, if it is axis, plan of axis making an angle, I think so. So plan means this is already 45 degree angle, and you just copy this figure. This plane in such a way that O7, that is plane of axis, is just lying on that line. You need not to draw the local. It is lying on that line. Any doubt? Like problem 7, problem 13 in your projection of lamina. I think you have done problem 13.
Yes, sir.
It is a similar problem, same problem.
Sir, please explain the upper part. I mean, above the horizontal plane. Cone.
Just you draw the projection one by one. First you draw the vertex. Vertex is here. Okay. Then 7 there. Then 14, 7, and just like one by one. 14 is on the middle. Here. One is 4, and 10 is other point. It is not 14 both are. This is your 4 and this is your 10. This is your 10. Okay. Then draw the projection of 10, and you get another point like this. And like this. One by one, you get all the 12 points.
Yes, sir. Understood.
Okay. And you
We got the points and add it.
this is your dotted. This will be inside part of your dotted. But while you rotating anti-clockwise, that circular part, elliptical part on the base, you can see completely. Okay. So this is your cone problem. Now I just give the hint of problem 8. Anybody can read the problem 8?
Project a cylinder of base diameter 50 millimeter and a height 60 millimeter resting on its circular rim on the horizontal plane. The base raised at an angle 30 degree with the horizontal plane, and the axis lies in the vertical plane, which make 45 degree with the vertical plane.
So this is your cone. It is telling what? Initially, you can start initially resting with horizontal plane. Okay, with circular base. Then you start. Draw the axis. Draw the circle. You can see a circle on the plane. Okay. Then draw the section. What you see in elevation? Tell it. Quick. Tell. What you see in elevation?
Rectangle.
Rectangle. Okay. Then you divide the circle into 12 equal parts. Same way. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Then draw the projection line. I do not put here names, everybody knows the name how. So on the bottom side, you put 1, 2, 3, 4, then on the top you should be A, B, okay? Like this. This is A there, and this is 1 there. And this is 7 there, A, B, C, D, E, F, G, and something like that. This is G there. Okay? Then, what is telling in your problem? It is telling base 50 millimeter, height 16, resting on a circular rim on HP, and base range at 30 degree with HP. This one base, we consider it 7, this is 7. So just this is 7 and make 30 degree angle base and copy this rectangle. Yeah. Center line and copy this rectangle. Okay. Then draw a projection. In between these two lines, you cannot see, you can see a ellipse, but you cannot see half portion. This is dotted. But on what top, you can see totally ellipse. Because you can see, while you see top, you can see total space. Okay, then draw a tangent line. And also draw the generating line, all the generating line. Therefore, thin line. Okay. Now tell me, is it completely satisfied the problem? This problem is, if we tell a rectangle is cylinder, base making an angle with horizontal plane and resting with this one circumference point, and draw the projection of this cylinder. So this is the. So now another condition in your problem, not that one, and axis lies vertical plane which makes an angle 45 degree with 50. So it is not telling the axis making an angle 45 degree, but it is telling that axis means a straight line. I think it is lying in some plane. A straight line is this axis, that means this straight line or this axis lying in some plane. So now can you tell me that plane is now in what condition with vertical plane? Not plane. This one
45 degree.
This one axis. This line is axis line. Okay. So I think this line is lying in some plane. So can you
Yes.
tell me which that plane is in what condition?
45 degree with vertical plane.
Now in this condition, if you find from this
Parallel.
now what condition that plane?
Parallel.
Parallel to vertical plane. Yes. Now this suppose if you consider a plane here, which is lying on the plane lying on that plane, that plane is now parallel to vertical plane. So now if you just copy this figure at an angle 45 degree, just rotation 45 degree is putting these two figures, putting these two point axis 45 degree. Okay. So that plane is taking 45 degree and just simply you copy this figure to it. Just copy. Noted? Copy this figure. Just copy by rotation and declare by direction 45 degree rotation and copy this figure then draw the projection. And you find. Now can you tell me what will be the elevation coming? Which side is dotted line? The rotation is anti-clockwise. Then bottom surface is totally in front of you or not? Say, I am rotating like this. It is like this. I am rotating like this. Now, tell.
Sir, the top surface can't be seen.
Yes, sir.
Cannot see. Some portion you cannot see, but bottom
Yes, sir.
portion you can see. So your figure will be bottom is this one. So draw the projection and you find and this is the resting point. This is resting point. Then you find totally this one and you cannot see that. Is it correct or not? Response.
Understood, sir.
So this is your projection of solids. Okay. So I give you three problems today, and in the same way, projection of lamina you can draw two horizontally and one vertically. Okay. Any question?
Sir, I have a question, but it's a little basic. Is it okay if I ask now?
What tell?
Sir, until now we've been learning how to, if you have any line which is perpendicular to the horizontal plane and parallel to the vertical plane, then we have been learning how to project it if it's been rotated left or right. Right. Well, it is still parallel to the vertical plane.
The line is parallel to vertical plane.
Yes, sir, the line is still parallel to vertical plane, but we rotate it at an angle to the horizontal plane. That we have learned how to project and draw. But I'm wondering if it has been rotated towards the vertical plane, how do we draw its projections on the vertical plane and horizontal plane? What steps do we follow?
Your question is a line is like this initially.
Yes, sir.
This is perpendicular to vertical plane and parallel to horizontal plane. Now, what you have to do?
Sir, I want to rotate it towards the horizontal plane.
Towards the horizontal plane.
Yes, sir. Well, the point which is perpendicular to the vertical plane, that is constant.
You just draw a projection. Let this is also find the areas and this is the same point.
Yes, sir. Keeping that point constant, if we rotate AB towards the horizontal plane. Like the point A remains the same, but B is rotated downwards towards the horizontal plane.
Is downward, okay. B is downward, like this. So it is coming
Yes,
here.
sir.
So in that case, you have to draw the initial side view.
Okay.
Okay, let's side view. How to draw the side view? Draw the projection line beyond the. This is profile line. For getting side view, this is your profile line.
Okay.
Then from this one, centering rotation. This is your A double dash side view. Okay.
Okay.
Now from B center, this is your B double dash. Okay. Okay.
Yes, sir.
Now you want to make this point as angle.
Okay, sir.
This is
Yes, sir.
angle.
Yes, sir.
Just make angle here. Rotation. This is your final B double dash. Then get the projection. Here, this is B dash.
Okay. Okay.
And finally you got elevation degree. And now you should draw the projection centering here, and this is your B. Final B. This is your plane. This
Okay.
is elevation, and this is finally your side view. Did you understand?
Yes, sir. I understand it. Thank you, sir.
Okay. So today I am ending. Any question?
Sir, I have a question, sir. Actually, while making the plate number 3, sir,
Yes.
there was a ellipse by projecting a circle, sir. The
Yes.
ellipse was not so smooth, like it has edges.
Yes.
After also using the French curve, sir, is it okay?
I just advise to you, uh, some points you are connecting with French curve, that's okay, but some point you cannot
Yes, sir.
with the ellipse. Then you can draw that one freehand, with freehand by matching with the initial curve. Okay?
Okay, sir.
Now, have you put your attendance in chat box?
Yes, sir.
Yes, sir.
Okay. So, can I ending the class?
Yes, sir.
Okay.
Thank you, sir.
Everybody can leave.
Thank you, sir.
Thank you, sir.
Thank you, sir.